Imagine that you drop a stone from a height. Once it leaves your hand, the only force acting on it is the force of gravity. The motion of an object under the influence of gravity alone is called free fall. Since there is no other force acting on it, all freely falling bodies are in a state of weightlessness. During such type of motion, all the bodies are accelerated. This acceleration is called acceleration due to gravity, and it is denoted by the small letter g. What is the unit of acceleration? It is meter per second square. So, the unit of acceleration due to gravity is also meter per second square. And now we need to find an equation for small letter g. Here we have an example. A ball is dropped from some height and the mass of the ball is small letter m, and this is earth. The mass of the earth is denoted by capital letter M. R is the radius of the earth. What will be the force acting on this particular mass? We know from Newton's law F is equal to ma. But here A is equal to g. So, the force acting between these two masses is F is equal to mg. From universal law of gravitation, we have another equation for F. F is equal to g small letter m into capital letter M divided by r square. From these two equations, we get g is equal to gm by r square. And putting all the values, we get g is equal to 9.8 meter per second square. This means that every body, when in free fall, will be increasing its speed by 9.8 meter per second every second. And what is the direction of g? As you can see, when the body is moving towards the earth, the direction of g is always towards the center of earth. And one of the most important peculiarity of g is that when the air resistance is neglected, all the bodies will be falling at the same rate. For example, if I drop a stone and feather from the same height, they will be falling at the rate of 9.8 meter per second square each second and will be reaching the ground at the same time. That is one of the most important peculiarity of acceleration due to gravity. Now, factors affecting g. The first factor is that shape of the earth. We know that earth is not a perfect sphere. It is a spheroid sphere. So, the value of g is not constant. It varies from place to place. Maximum g is at poles and minimum g is at the equator. And the second factor is altitude. As the height from the surface increases, g decreases and it is 0 at infinite distance. And third factor is depth. As the depth from the surface increases, g decreases and it is 0 at the center of the earth. So, these are the three important factors affecting g. Now, we are going to see the equations of motion for a freely falling body. But before you set the equations, you need to know the sign for g. When a body is moving towards the earth or falling downwards, g is taken as positive. When the body is moving upwards, g is taken as negative. Here you have an example. I am going to drop one ball from a height h. What is the initial velocity? Initial velocity u is equal to 0. As it falls down, what is the direction of g? It is towards the earth. What will happen to the speed? Speed increases. Let's see the equations. So, v is equal to u plus gt. Why plus? Because g is towards the earth. And the second equation is s is equal to ut plus half gt square. And u is equal to 0. We get s is equal to half gt square. And s is equal to h. From that equation, we can find the height and time of flight. And the third equation is v square is equal to u square plus 2gs. Again, you can put u is equal to 0. We get v square is equal to 2gs. These are the set of equations for downward motion. Now, let's see the equation for upward motion. Here, we know that g is acting downwards, but the ball is moving upwards. What will happen to the speed? It decreases and reaches 0 at maximum height. So, v is equal to 0. What is the sign for g? It is negative. Let's set the equations of motion for this motion. V is equal to u minus gt. S is equal to ut minus half gt square. And v square is equal to u square minus 2gs. These are the set of equations for upward motion. Now we have an interesting topic, that is mass and weight. Generally, we confuse these terms. What is the difference between mass and weight? Mass is the amount of matter present in this body. It is a constant. It is not going to change from place to place. It is a scalar quantity, and what is the unit of mass? It is kilogram. And the second quantity is weight. Weight is the gravitational force acting on a body, and it is a vector because it is a force. What is the unit of force? It is Newton. So, what is the unit of weight? It is again Newton. What is the relationship between mass and weight then? F is equal to mg. That is, W is equal to mg. So, one is a scalar quantity which is a constant, and this is a vector quantity and is a variable. From place to place, weight can change.